So that's going to be log base E of 250. All right, so now can I solve this equation for t? Yeah, this is just a number, right? Log base E of 2.6, whatever, what power you raise E to get 2.61. It's going to be very close to 1, a little bit less than 1, right? Because E to the 1 is 2.718, right? It's just a little bit less than that, it would be like 0.9 or something. So T is going to be log to base E of 250 divided by log to base E of 2.61. So by just taking the log of both sides and using the fact that it's 1 to 1 and I have this property of exponents, I can solve for T in terms of log base E instead of log base 2.61, which is awkward. So should we try that? Are we supposed to get a little bit more than 5.7? Closer to 5.7 than 5.8, I believe. So if I say 250 and then I say natural log. Oh, yeah, sorry, this one goes the other way around. So I got to clear this out, right? Oh, I see. That's how you undo. So I say first natural log, then I say 250. Then what? Arrow over or something? I don't know. Divided by?
Oh, there's it. It's right there.
Close the parenthesis. Okay, so it's got a grayed out parenthesis, but yeah. And then divided by, I guess, log of 2.61. That was an approximation, but it's pretty close. And then equals 5.75. So that pushes it over to the other side, right? So in fact, it's not 2.61, but it was close, right? I forget, it was 13 twelfths to the 12th power. So that's, so what do we do? Okay, so 13 divided by, so these things are very sensitive sometimes. So we get this as our base. We raise that to the 12th power. So here comes an exponent 12. And we get a little bit more than 2.61, right? So log base E is something a little bit more than 2.61. It's going to be a little bit greater. I'm going to divide by a larger number and get a smaller number. So there's no way, there's no memory for this thing, huh? Okay. So I suppose you can do this, right? Copy. Yeah, memory. So I'm going to say, clear this out, and then say log of 250, was that it? Close parentheses, divided by log of paste. Oh, you can't paste that way? Oh. Well, I guess we'll have to say 2.613, I think is what it was, as I recall. Yeah. So that's now 5.74. That's closer to 5.7 than 5.8, and so that's what we wanted to get. All right. Very, very sensitive to those digits, though. All right, so that's that. Okay, how about my open math? Let's see what's going on there. Get started on some of these problems. So myopenmath.com. We've got me signing in as me. And then oh, somebody's got a message for me. I'll read that later. So 4.2, do we want to try a few of those, or did anybody have questions from 4.1? You got one? So what's going on here? Let's sample every fifth one. Okay, so draw the graph of negative 2 to the x. Well, the order of operations is important here, right? Which happens first, the negation or the exponentiation?
Exponentiation.
Yeah. Yeah, if you wanted to raise negative 2 to the power x, you put it in parentheses. Right? This is then first apply the power x to the number 2 and then negate that. So what does that mean? Well, that means that it's all negative, right? 2 to the x is always positive. If you negate a positive number, you get a negative number. 2 to the 0 is 1. 2 to the 1 is 2, and the negation of 2 is negative 2. So there we go. That's all we need, right? 2 points determine the curve, and so that's good. Number 10. So this has got a horizontal asymptote. It's 4 to the x shifted up 2, right? 4 to the x has the horizontal asymptote y equals 0, so this is y equals 2. And graph the list 2 key points. Domain, range, and equation for the asymptote. So 2 key points apparently, all right, so 3, no, they're not, yeah. And, oh, I'm using the wrong tool. This is the square root tool, right? So I want the exponentiation tool. So if x is 0, this is 3, okay, and then, all right, so that looks like if x is 1, that's going to be 6, right? They didn't scale their axes, so minus 10. If I'm grading their problem, give them a minus. What's the domain? It's going to be all real numbers, right? In interval notation, you enter that like so. The range, 2 and above, not including 2. And let's see, can we, I guess, we can't, you're not going to give us a preview of this, huh? So the asymptote, well, that's the line y equals 2, right? All right, everything seems happy here, so we're moving on to 15. Bank features a savings account, has an annual percentage rate 3.7 with interest compounded quarterly. That's n equals 4, right? So you deposit 12,000 in an account according to the model we use in class. Is there some other model? What values should we be used for? So P would be 12,000, R would be 0.037, and N would be 4, right?
Would that 3.7 be over like a quarter, over 4?
Yeah, no, R is the annual interest rate. It turns out the interest rate per compounding period you divide by 4, but the annual interest rate is R. So that's what R is. N is 4. But yeah, when you plug into the formula, what would you get? Well, you'd get, here we should do a little scrub work. How about 12,000 times 1 plus